What's going on YouTube? Today we're going to be going over an interesting example of specific heats. Have you ever wondered how to get your drinks coldest the fastest or to keep them cold? Well, that's the exact question we're going to be looking at today and diving into some of those concepts because I know this is a chemistry problem I remember from college. So, specific heat, what is it? Specific heat is the amount of energy that is required to change a certain amount of mass of an object by 1 degree Celsius. So you may have wondered, why do I always use ice to keep my drinks cold? Well, that's exactly what we're looking at right here. So ice and water have the same specific heat, and it's a very high specific heat per gram. It's actually 4.186 joules per grams Kelvin. So to break that down, I have the equation up above for how to calculate specific heat, where you have energy over delta T. And if you were looking at a problem in this case, and you were looking at how much energy was required to change a drink's temperature, you would have energy equals mass times the specific heat times delta T. So as I said before, here's the specific heat of water, and you may be wondering, why don't we use other objects in drinks to keep them cold? So I know I've been looking on the internet before, and I've seen some of these cool things for putting in your liquor glasses, like stainless steel spheres or silicone spheres that you put in the freezer, and you cool them down, and then you're going to put them in your drinks, and they're supposed to be comparable to ice. So the specific heat of metals in, for instance, stainless steel is a lot lower than water or ice, and silicone's a little bit higher, but it's not as dense. So there's a factor in play there where you have density, which relates the mass to the volume, where you may have the same size object, but it's going to weigh a lot more. So the specific, or the amount of energy that would be exchanged with the drink could be comparable in that sense from a volume basis because of the density. But there's one really key attribute that you use when you use ice in a drink, and that relates to the heat of fusion. Okay, so when ice melts, it takes a certain amount of energy to be put into that cube of ice to get it to convert from a solid to a liquid. And this is a really high amount of energy, 333.55 joules per gram. I mean, we're talking in the realm of close to 100 times what the specific heat of a single gram of water would be. And so the fact that you're melting that ice is the big key as to why your drinks get so cold and can stay cold. Because it takes a lot of energy for that drink to pour into the ice in order to melt it. So another part of the question that we were looking at was, how do you cool your drinks down faster, or what would be the best type of shape of ice to use for specific drink applications? So I know my wife loves nugget ice. A lot of fast food restaurants or things like that you drive through, they've got nugget ice, okay? And that's going to cool your drink down a lot faster than bigger ice cubes that you might get. And there's also some factors in play there based on the shape of the ice that's coming out. So you could say that a nugget's pretty close to a cube, and I've got some information here about a cube, and I've got some information here about a sphere, and we're going to look at which one would be better for different applications. So the rate at which your ice cube is melting is based on the surface area to volume ratio. And so the surface area that is exposed to the drink, that's the ice that's being changed temperature. And so the more surface area you have, the more that ice is being exposed, right? But if you also reduce the volume to a really small piece, like nugget ice, for instance, usually those are pretty small, you're looking at a really rapid rate because you could fit more nugget ice in, where you might have if you used other types of ice, you might not be able to fit as much into that space, and so it's exposed to more of the drink, and it's causing your drink to get colder faster. So for instance, let's say you have soda, right? You want to use nugget ice for that because you don't really care how much you dilute the soda. Most likely, you're drinking it pretty quickly, and as that ice melts, it's becoming a part of the solution and mixing in there. So your soda's getting watered down, but you're drinking it so fast you don't really care, and you just want it to be cold, right? On a hot summer day, you want a cold soda. But let's say, for instance, you're at home and you want a nice glass of liquor, right? You don't want your liquor to be diluted. So in that case, the best type of ice to use would be a sphere because it has a lower surface area to volume ratio. So if you used a big sphere in the middle of your drink, it's going to take longer to get your drink cold, but it's going to keep it longer without diluting your alcohol. Now, I don't know about you, but that's a pretty interesting concept, and it's a nice way to see how this world works and some of the things we've always done but never really thought about. So if you like this type of information, you learned something new, hit the like below. Comment on anything that I went through if I missed something that you would have rather seen, or send me a comment for another question you might want me to look at, and we can put it on the docket for something to look at. This is STEM Explained, and I'll see you in the next video.